This is the Earth Science Classroom. Welcome back to the channel. This video is in the Earth as a System playlist or series of videos looking at the Earth and its different components, its spheres, how it functions, and each sphere in more detail of what is included in each sphere, and a little bit about how they interact with other spheres to create our living planet, our living world. So this video is on the atmosphere, our lovely body of gas or volume of gas that surrounds our planet, and we're going to look at what's included in the atmosphere, different components and parts, and how it functions as a sphere or a part of the Earth as a very large working system. So our atmosphere is a beautiful thin layer of gas, a bunch of air molecules that are held in place by gravity around the Earth's surface, extending from the surface to about 100 kilometers in the air. Now, this is a topic of immense beauty, a topic of art and inspiration, and ever-changing medium that everyone can experience and see every day of their lives, from daily weather to long-term climate. So our atmosphere is composed of gas, air molecules, and these air molecules come in different types. The three main types, or three main gases that make up the atmosphere, are nitrogen, oxygen, and argon. Now, nitrogen is the main constituent in the atmosphere of 78.08%, and it comes in a diatomic form of N2. Then next you have the oxygen, again diatomic, O2. So you have a little bond between the two oxygen elements, and that is 20.95%. Then you've got argon, which is 0.93%, which is that third gas, which no one really knows about, but it's there in the atmosphere. Now, beyond that, we have what's called the variable gases, which can vary in amounts depending on location around the Earth and what the atmosphere is doing at the time. And these gases are methane, CH4, water, CO2, and these can also be classified as the greenhouse gases. Next, you have the trace gases, which equate to about 0.1% of the atmospheric composition. Now, these trace gases are very small in amount, and they can vary from different oxides to neon to helium to hydrogen, and these gases are included in the atmosphere in very small amounts. Then you have the aerosols, the small particulate matter and the cloud condensation nuclei, the small particles like pollen, dust, sea spray that can help to form clouds. So the atmosphere is that amazing interacting layer that first receives the incoming solar radiation, or the EM spectrum, that the sun provides us. Now it takes about 8 minutes 14 seconds for the sun's energy to reach us, and once it does, the atmosphere is that first layer that either distributes the energy, or based on the shape and the tilt of the Earth, can help to distribute the energy from the hotter equator to the more colder poles. Now, some of the energy does bounce off and reflect back into space, which is called albedo, and this is about 30% of the energy we receive, so we keep about 70. Now, that 70% of the energy then goes into the clouds, it goes into the air and the atmosphere, and we get the three layers of thermodynamic movement of heat, which is convection, conduction, and radiation, and that also works inside the atmosphere to transfer heat and create all the cycles we experience. So our atmosphere is made of air and held by gravity, nitrogen, oxygen, argon. Now, the atmosphere goes from the surface up to about 100 kilometers, which is the general consensus of where space starts. Now, space is the absence of air molecules. So our atmosphere, even though it's thin, is divided into 5 distinct layers. The first layer is called the troposphere. Now, the troposphere is what we experience, what we breathe air from, and we experience it every day with weather and wind and climate. There is some weather and some clouds go into the next layer, the stratosphere, but the majority is in the troposphere. Now, it's very thin, it has the majority of the air pressure because the air is brought down by gravity, so you have the bunching up of air molecules, thus the higher air pressure. So the troposphere goes from about 0 kilometers, it does, up to about 18 to 20, depends on the latitude. Now, the next layer is the stratosphere. Now, this is important because it involves the ozone, which is O3, 3 oxygen molecules binding together, and ozone loves to eat or draw in radiation, ultraviolet radiation from the sun. Now, it lets in A and kind of like controls B, and the more harmful C is absorbed and reflected by the ozone. Then we have the mesosphere. The mesosphere is the middle layer, hence meso or meso, which is middle, and this is really basically just going to be the first layer where air molecules are concentrated enough that meteors or incoming rocks from space are going to start to combust based on the friction with the air molecules. So the mesosphere goes from about 50 kilometers altitude up to about 80 or 85, and the mesosphere also is the coldest layer of the atmosphere. Next you have the thermosphere. Thermo means heat. So this layer denotes heat. Now it's really far from the Earth's surface, so we're thinking it's not going to be heated by the Earth's surface, but it's heated by radiation from the sun. Now, thermosphere has very, very low air pressure. It means the air molecules are really spaced apart, and gravity is not really held in place, as less accumulation. So the thermosphere is called the thermosphere because the air molecules absorb the intense radiation from the sun, get really hot, but temperature is cold because they can't knock or collide and create temperature because they're so far apart because of lack of gravity. Then in the thermosphere you also have the ionosphere, which creates the aurora borealis and aurora australis in the southern hemisphere, and also have the magnetosphere, which is again the charged electrons and ions which deflect the solar winds from the sun. And then above the thermosphere with the exosphere that can extend up to 20,000 miles away from the sun and really is the exterior of our atmosphere. So our atmosphere has a set of functions that a purpose and certain processes that occur within the atmosphere that support life on the planet and support other systems in addition to itself and the atmosphere and what goes on within the atmosphere, but also the interactions with other spheres like the geosphere, hydrosphere, and of course the biosphere. So you have the exchange of gases between oxygen and CO2 and nitrogen in different cycles, which are the biogeochemical cycles, which flow throughout the atmosphere and the surface of the Earth, and obviously space, the interaction with space in terms of the atmosphere's protection of the surface through the burn-up of meteors like in mesosphere. So life is supported through the role of gases and respiration of oxygen and CO2 through either animal species, flora and fauna, and how we can have these beautiful lush ecosystems on the planet because of the atmosphere. Then also looking at the weather and climate, so the day-to-day or even minute-to-minute changes of the water cycle with precip, condensation, evaporation, and the formation of clouds, and obviously precip hitting the Earth's surface. So in all these functions combined, we produce a dynamic and ever-changing atmosphere which plays an important part in everyone's lives and the changes in geomorphology of the Earth's surface. And obviously precip is a major thing. Water is a major weather and erosional agent, and when you combine the temperature and pressure you get the evaporation and condensation of water vapor, and of course you get temperature rising through the atmosphere. You get these beautiful large cloud formations, in this case a cumulonimbus cloud single cell or multi-cell formation, and you see the immense heat and energy that's trapped in the atmosphere, creating these beautiful storm systems, and they can move across the Earth's surface, providing water, providing some change of temperature, and you get this effect on the Earth's surface and the other spheres because of the atmosphere's dynamic nature. Now we're looking at the troposphere right here, and the top of this anvil cloud, this cumulus cloud, is showing you where there is a limit of adiabatic heat rising and where the pause happens between the troposphere and the stratosphere, around maybe 40,000 feet in this case. So when you combine these cumulus clouds through wind and they join together and they start to rotate because of the Earth's spin and the Coriolis effect, you get these formations of tropical low pressure systems or cyclonic systems called hurricanes or typhoons, based on which ocean basin they form off. Now you need an ocean basin because of the water, evaporation, and a certain heat, but this happens around the tropics. These beautiful large systems that are created, and of course it brings these extreme weather systems, and you get the high winds, you get the high swell and waves and tidal surges and storm surges, and you get the wind that's going to push and create destruction on the land and coastal areas, and you're going to get the large precip and flooding, and all these happen because of the weather, because of the extreme nature of temperature and pressure and the accumulation of clouds in certain areas of the world and the flow and movement of these clouds. Now then you get the release of energy, lightning and thunder, and the beautiful show that it creates in the atmosphere. So in conclusion, our atmosphere is one of the spheres, one of the connecting pieces of the Earth's natural planets and natural cycles. It is made of gas, air molecules. It plays an important role in the flow and movement of biogeochemical cycles, life-supporting systems, and can change day to day and even over the course of the Earth's history. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and hit the like button. If you like more on this content, please check out my channel, which has all these videos on Earth science.